I hope you're having a good morning, evening everywhere. So, I'll introduce myself. I'm Suchakra Sharma. I'm the chief scientist here at Privado. I deal with all the weeds of the technology that we see inside the system. And with me is Nishant.
Thank you, Suchakra. I run the Privacy Center of Excellence at Privado, and I've written a book on the topic. So thank you for joining us. Back to you, Suchakra.
Yep. Okay. So today is going to be an interesting day. We are going to learn about software and the role of software in privacy. So this is going to be interesting for privacy professionals because we always see what software is going to do, but we completely do not understand the process in the way in the process in which software is built and actually shipped. And it's very interesting to understand that, because once you know that, you know where the fixes of privacy issues that you see surfacing live in the systems, where those fixes can be applied, and you can kind of like plug the hole of the leaks, metaphorically. Okay, software is the central piece of everything. That's how I see it. Any data that you see in databases, the data that you see in your Google Sheets, everywhere, this is all created in software. It's moved from software from one place to another place, and that's essentially what happens inside the system. So the way to really fix any issue that might be occurring is going to be inside the software. So that's what happens. Data gets collected, shared, it gets used and stored, and it's all happening because of software itself. So let's try to understand what happens inside software. So the creation of data starts with code, and this is kind of like a funnel. It's from Nishant's book. If you have a chance, you should read it. And this funnel explains that at the inception of any software, it's just code. It's code written by developers, engineers, etc. And at that point, there is no data. But as soon as the code is built, it starts getting deployed, becomes a website, mobile app, or some analytics service get added to it. It starts adding data to it. Once it starts running, there is data flowing through the code, and the funnel of the data increases. So think of this funnel as the total size of data that is increasing. And the way to try to fix issues or try to understand where private data is going these days is actually happening on the more towards the right side, where the data has already reached databases. It's huge, and we are trying to sift through it, trying to understand exactly what is happening. So my modern privacy tools and the efforts which we have on fixing privacy are more towards this region. This is a bit late and reactive. That's what we see, because now you have the whole ocean to clean and put it in a bottle. You cannot do that. The earlier you try to prevent it, earlier in the game you try to understand, that's going to be much more efficient, and that's what we see. Okay, so let's now dig a little bit more deep. What is happening inside the software? We looked at this funnel. We try to understand the databases, but let's try to understand how is this code even developed or written. So software is going through this cycle. Think of it like a wheel of your cycle. You're continuously running. You're strategizing, designing, developing, testing, and then releasing. And then now again the cycle changes. So this is kind of like how software is developed at a very high level. But modern software is much more complex. We follow this strategy of agile development these days in the industry, where small pieces are developed very fast and the changes are very frequent. You have seen, you're using a mobile app, and tomorrow the mobile app changes, a new feature has been added. And because of this speed of changes, the privacy issues that could occur inside the software or could be seeded in them is also exponentially high. So it makes sense to try to understand what is happening inside the software. So throughout the presentation, we'll try to go through these individual steps of software development and see what happens. So one of the things that happen because of this early release and the late release is longer features such as complete development, redesign, etc. They will take a lot of time, but the smaller things, small bug fixes, some design changes, they are very fast. So to match up with the speed and try to understand, we will try to understand what software is. The first step would be planning and strategizing. So here we will sit, understand design documents, understand how requirements are there, and we'll try to make sense of what is happening inside. So at this stage, no development has even begun. We are just sitting around in a table, understanding that we have to have this kind of high level feature inside the software. What should we do? At this point, we are just thinking of, okay, maybe we should have this. Okay, we need to track analytics inside the application. Should we take the location of the person? We're just thinking about it. And at this point, it's very important to do a very thorough analysis. And I think Nishant can chip in, because the planning is the core
Yeah.
phase of privacy that happens here.
Yeah. So if you go back to the diagram, Suchak, I'm going to go back a couple of slides to the funnel that you talked about.
Yep.
So part of
Um,
what we're talking about here, folks, is the fact that if you want to do governance of data, if you want to go for efficiency, de-risking, compliance, whatever your goal may be, you want to do it as early as possible, because at this point, multiple conversations are happening. You're seeing designs, architecture, you're seeing deployments, you're seeing testing, all of this. So you have multiple product cycles happening at the same time, and each doing its own thing. And you want, for example, your AI models to detect risk much earlier in the process. The only way you can do that is to move shift left and use automation, because otherwise you'll end up with manual checkbox compliance, multiple projects in a row, a thinly staffed legal team, an angry engineering team, right? So when we talk about shift left, that's why, because if it was important 10 years ago for security, 5 years ago for privacy, it's going to be even more important for LLMs today, because if there is no way you can learn all these things on the cheap. So it's important for you to shift left purely because of the points Chakra is making.
Yeah, and the earlier we try to understand the systems, the earlier we try to fix, the less we'll have to clean the big flow of data that has already happened. It's kind of like a hose that has been turned on and the data is everywhere. So you try to understand where the data is even starting. Try to understand where the water has started to trickle from, rather than trying to understand the tank that has been filled now. So the second phase is design, where all the decisions that we took of what to do with the data would now be, distilled into documents. We will understand where we are going to send. For example, okay, we'll start using Stripe. We have to make payments. Let's start using Stripe. So these high-level decisions will be made, and during that time, a few things could happen. You have not thought about how authentication could work properly. A person who has made a payment, you have decided that, oh, we have turned on this specific feature inside our payment system, and now the data is flowing out from somewhere else. So these kind of risks could occur. At this stage, it's very important to understand what your data flows are going to look like, and not just understand what the application flows are going to look like. So this is a key component. Next would be actual development, and that's where the delta also occurs inside the systems. As we have seen, the design would say something, and when the thing actually gets developed, a new SDK has been added. Somebody from marketing came and said, hey, can you please add this also? And the developer sits there, they said, oh fine, now you're bothering me too much, let me add this. So that actually could happen. And in this case, someone says we need analytics on everyone who is visiting our app, and the developer decides to take in the profile pictures, send them to OpenAI. And if something like that happens, a violation has occurred. It was not planned. It went through the planning phase, but it was not planned properly. But this occurred, and we have to fix these kind of issues. And here, what would be the best way is to not just have normal PIAs that you run during the planning phase, but to have technical PIAs as the code has been developed or is being developed. You try to understand you try to scan the software and try to understand what could be a real privacy issue that occurs here with the evidence. So at this stage, if you run a technical PIA, you would have an evidence of what is being done. And if you fix it, you would automatically magically implement privacy by design. So implementing privacy by design is going to happen at the stage where software is being developed. You have scanned it, and you now can clearly have an evidence-based fix that could be applied. So the next phase is testing. So once the software is developed and developers have signed off on it, you would be testing it. And at this stage, what could happen is that an actual customer's data could be used for testing, and that causes a privacy violation. So it's interesting to use this phase of testing where things are a little bit paused because they've not yet been released to the public. You could use this situation to also run your privacy tests. So any other post coding tests that have to be done, you could actually run at this stage as well and leverage the stage of testing. Once testing is done, the software is released. It's available on App Store, and everybody can do it. At this stage, a real live testing could be done to ensure that compliance is there. So you could test your websites, your apps, kind of like an outside in view of your application. This is the kind of privacy test you could do. So what we have seen so far that is that privacy engineering is can be implemented throughout the life cycle, throughout it's like a spectrum that you have to insert throughout the development of the software. And once you do it right, from coding, building, and releasing it out, and all the way to the databases that would store finally the data, you could have this privacy engineering implemented throughout the software. And once you understand software, that becomes much more easy to decide in what phases you should implement privacy engineering. uh, so with that, I'll give to stage to Nishant. Maybe he can like round this up and give us a more clear understanding of what we have learned.
Yeah. It's like what Suchakra said, you are accruing risks during the innovation phase because you don't know what's happening at that point. And the ideas, there's whiteboards, there's models, there's new code, there's old services. I have been in companies that are extremely sophisticated when it comes to tech stacks and whatnot, but I've seen comments in line of code saying, don't delete this when the service goes down. So you end up with these problems because you didn't exactly have governance in place before the code into production and adoption took place. So these risks begin with software, and the bet we're making at this event is to say that a problem that starts with software will end with software. Automation will cut automation, right? So hence the investment is shifted as much as possible. The second thing I want to say is that don't wait for regulation or compliance to tell you to do the right thing. Like as much as possible, you want to make sure that you use user trust, and it's easier to do because you are trying to convince your engineers that something bad will happen if they don't optimize for trust. And you can, with these techniques which I've just talked about, identify areas that will be true. And with that initial trust in place, you can then work with the engineering PM teams to build for trust for your end customers. And then finally, the point is these checks have to happen throughout the SDLC. Like you cannot just do it at the beginning or the end because innovation happens at every stage in the process. Initially, it was all about waterfall, it happened at the end, or about agile, which just happened at the beginning. But now it's a mix of both, right? So you want to make sure that you have these disciplines across the board. So the key takeaways are software, 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 trust more than compliance in the beginning at least, and then finally check early, check often, check always. Back
Yeah.
to you, Jakarta.
Yeah, and I think I'll give a little bit of my personal perspective also by while looking at privacy. It's been quite some time in privacy now. I've been in security, and I've seen this whole concept of shifting left work very well in security, because the earlier you would try to fix bugs, the less issues they are going to cause something later. And actually, when these issues occur, what is the goal of anybody who is trying to attack a software? Is to extract data from it. So the earlier you try to fix issues, earlier the less data your software would even collect, the more secure the whole system is. So these things are very intricately linked: the development of software, the bugs that happen inside the software, and the privacy violations the software might cause. They're very well interlinked, and they have to be. And that's why it's important for privacy professionals to also understand how the whole cycle of software development works. In the last session, we had this nice quote: trust doesn't happen by accident. And that actually is very true here. Trust doesn't happen by accident. You have to actually prove it. You have to give an evidence of how, at what point inside the software this trust is getting broken. And while doing this scanning early, scanning the software before it's released, just after it's released, before it's even public to the system, you could actually earn that trust. You could give an evidence that, yeah, we are fine. We are not collecting this data. We are not sending it into these databases which are violating a certain privacy guideline that we have. Okay, so I think with that, we would conclude. And any questions, if they are, we can take them now. Okay, so yeah, this approach can be applied when building an AI system uh, where there is very less code. Okay, yes. So uh, AI systems obviously are going to have some sort of interactions where developers are going to write, certain prompts, and that's what we have also observed in large organizations. A lot of the data that is collected from the software, for example, an organization that deals with, I don't know, food. They're going to collect health data of a lot of people, their dietary information, etc., and they want to analyze it. So what we have seen is that this can get shipped to other analytics services, and these analytics services are going to have now access to this data. And these analytics services often use a lot of AI in them, and developers would write literally AI pipelines to extract this data and manipulate this data. If you try to understand the software development lifecycle and try to fix issues early, you would exactly know at that this point inside the software, the data is being fetched from from the software, and is being sent to OpenAI for analysis. So I think there is an opportunity in AI systems, to have a clear understanding of where the data is going, if that is applied.
Great.
There's another question. I'm just reading it out. So, who is the audience to present this solution to? We are developing a data lakehouse, and I want this to be demoed to my company. I'm not really getting any traction. All the tools are basically security by design, but they don't translate this type of product, and there's a lot of manual intervention. Yeah, that's a very good questions. I think that's where one of the slides that we were discussing comes into the picture. That uh, the privacy teams, there is this kind of like this gap, this gap where privacy teams are not really completely understanding how software is developed, and the software teams are not gelling well. So when you have a good communication between this, then it would happen. uh, I would say, a joint session, and some very successful companies are doing this now. They do not call their teams as privacy teams, they do not call their teams as security teams, they call their teams as trust teams, because it's kind of like an intersection of both of them. So I would say, find common stakeholders in privacy as well as trust, bring them to the table, explain to them that software is the core issue where privacy bugs would be occurring, and they are at this intersection of security. And at that time, this concept of, okay, secure by design or privacy by design, it gels completely inside, because essentially what you would see here is that privacy issues are going to be exacerbated by security issues that are going to happen. So they are at the intersection, and they should both be sitting at the table, I would say. Anything else you would want to add, Nishant, on this?
I think you got it all there.
Yep. So there's another question. Like in security, do you suggest to apply privacy threat modeling in SDLC? That's a very good question. I would like to see. I would like to see the privacy engineering community really move towards that. Threat modeling has been a very, very successful technique that has been used in security. I think MITRE has already come up with a nice plan to do privacy threat models. I'm not exactly sure what they call it, but you can actually start applying that. So it's very similar to insecurity, the attack framework that is there. There is a similar privacy framework for MITRE also that can now be used to do very preliminary threat modeling for privacy. I think that's a good point. We could call them privacy threats because essentially they are threats. someone's data getting leaked is a threat. And I think people uh, uh, people should really understand what I would say is this intersection that exists between security and privacy. And the goal of any bug, any security bug that exists, is to actually exfiltrate data. If you think about a very difficult to find bug happening inside the system, the goal of many of the attacks that happen is to just exfiltrate data. So to try to prevent this data from even reaching these points where attackers can access it, is the key here. So this could all like intersect. Security threat modeling, privacy threat modeling could actually intersect completely.
That was a great question, by the way. Yeah.
Yep. Okay, so I think that's about it. We have answered almost all the questions here. I'm just gonna quickly look at the chat. I think we are good. Someone wants to go back to slide 4. Uh, we'll share the slides after the session is over with everyone so they can review and see. Okay, I think with that we
Yeah.
can conclude the session.
Just one last thing. There's a comment from Anita Whitby about a course. The course you're referring to, Anita, is kind of an old one. So I would rather push you towards the masterclass that we have built with Privado. So if you Google my name with Privado and masterclass, you'll see the course. That's a much better, much newer course. So